All right, section 1.2 is a lot more properties. Again, not nearly as much algebra here. We're going to start talking about interval notation and then domain and range. Domain and range are some of the most important things that we're going to review this semester. I say review because you should know them, but in case you don't, let's talk about them. So before we get there, a reminder about interval notation. Interval notation is a start and a stop value. So where does this start and where does it stop? And remember that we use parentheses. Those are symbols of exclusion, meaning the number next to the parentheses is not included in my set of numbers. We use those the same time we see just greater than or less than, or on a graph if we see an open circle. And then my brackets are symbols of inclusion. That means the number next to the bracket is always included in my set. And we use the brackets when we see less than, greater than or equal to, or less than or equal to, or a closed dot. We also use brackets if it's on a graph, if it's a point on a graph, because a point would be a closed dot. And I forgot to mention up here that we always use parentheses with infinity. Infinity is not a part of a set. It is the idea that the set continues forever. So since infinity is not included in the set, we use parentheses. All right, so here, this set starts at -2, and -2 gets a bracket because it is included. I know that because it has the or equal to. And it ends at 0, and 0 gets a parenthesis because 0 is not included. It's everything between -2 and 0, not including 0. So you get right up next to 0, but you don't include 0. Okay? And so then here we would say, okay, well, this is 3 to 8, 3 with a parenthesis, 8 with a bracket, again, because we have no or equal to, and we have the or equal to. And or we do a U, capital U. Or, and then this would start at 16, 16 not included because it does not have the or equal to, and go on forever. Okay? All right. So remember that domain or the x values are the input. Range are the y values or output. So if I'm asked for the domain, you need to use one of these curly brackets, one of those right there, and you list the x values. They should be listed in order from least to greatest. So this would be -17, -4, 4, 17, 32, 44. And then close your brackets. Commas in between each one, please. Moore's going to get really picky about notation. Okay? And see, it even tells you right here in numerical order. So then for the range, we're going to do the y values. It looks like 16 is the smallest, and then 18, and then 45, 51, 83, 94. So to back up here to answer your question, when you only have an x and one number, one of your things is going to be infinity, yes. If it had been x is less than 16, it would have been negative infinity to 16 because it's all the numbers on this side of 16. Does that make sense? So when you have two numbers like this, when you have a compound inequality where the x is between, this is your start value, this is your stop value. When you only have a greater than or less than, if you have greater than, then you're going to stop at infinity. If you have less than, then you start at negative infinity. Sorry, I didn't see your question sooner. Move this to a place where it's more in my face. Did that answer your question, Evelyn? Okay. Thank you. Like you said, I'm sorry I missed you. Okay, so here, domain are the x's, again, written in order. So negative 4, 4. Fortunately, they were given to us in order, 34, 38, 42. And then range are the y's. So my smallest one looks like it's 20, 49, 59, 66, 67, 88. When they're not in order, I cross them off just so that I know I included them. Okay. Now, if you're given a graph and asked to find the domain and range, domain is left to right and range is up and down. So here from left to right, we start at -2, and -2 has an open circle, so it gets a parenthesis. And we stop at 3. 3 has a closed circle, so it gets a bracket. And for range, we go bottom to top. So we start at the bottom at -5, and -5 gets a bracket. And then we stop at the top at 4, and 4 gets a bracket as well because it is on the line. Any point on the line would be a closed dot if we were to graph that point. So any point on the line gets a bracket. Okay. All right. So domain and range here, we go from left to right again. So we're starting at 1. Now, the only thing that I don't like about this is it doesn't imply that it goes on forever with arrowheads, but it also doesn't imply that it stops because there's no dot. So we're going to just pretend there's an arrowhead there when you're looking at your computer. And then this one will continue to go right forever, which means that we're going to put an infinity there. And then the range bottom to top, it goes down forever. So that would be negative infinity. And it stops, its highest point is here at 4. And again, that is a point on the graph. So that means 4 gets a bracket. Now, when we're looking at function definitions, for right now, every type of function that you've learned or that you should have learned has an infinity of all real numbers, except for rationals and roots. So if you see a linear function or a quadratic function or any other polynomial, those all have a domain of all real numbers. We have special cases here in rationals and radicals because with a rational, your denominator cannot equal 0. So what we're going to do is we're going to set the denominator equal to 0 and see where would that happen. So we have x squared plus 11x plus 30 equals 0. Two numbers that multiply to 30 and add to 11 are 5 and 6. So then x plus 5 equals 0 or x plus 6 equals 0. So either x equals -5 or x equals -6. So if I plugged in a -5 or I plugged in a -6, that denominator would be 0, and that would be no good because we can't have 0 in the denominator of a fraction. So that means that my domain here is everything, all real numbers, except -5 and -6. So when we're notating that in interval notation, I'm going to write it up here instead of in the box. We would say everything to the left of -6, everything in between -6 and -5, and everything to the right of -5. Noticing that -6 and -5 both have parentheses, which means they are not included, but everything to the left of -6 is included, everything in between -6 and -5 is included, and everything to the right of -5 is included. So this is how we say all real numbers except in interval notation. Okay? Now, my other special type of function are radicals, and this is only true of even roots. Odd roots, so cube roots or fifth roots, those have a domain of all real numbers because you can do the cube root of -125, that's -5. But you can't do the square root of -25 without going off into imaginary numbers. So when we're thinking about domain, we know that we cannot take the square root of a negative. So we need to know where is our radicand. We need the radicand to be greater than or equal to 0. So we're going to say, okay, the domain of this function is everywhere that 3 minus 4u is greater than or equal to 0. And then we're going to solve. Subtract the 3. And now I'm going to divide by the -4, keeping in mind that with an inequality, when I multiply or divide by a negative, I have to flip that sign. So this would be u is less than or equal to 3/4. So in interval notation, I would say that that is all of the numbers to the left of -3/4, including -3/4, because you are allowed to take the square root of 0. The square root of 0 is 0. So it gets a bracket. So this is all of the numbers to the left of 3/4, including, or -3/4, excuse me. Nope, +3/4. Shouldn't have put a negative sign there. All of the numbers to the left of 3/4, including 3/4. A little bit of algebra. Okay. So then the last thing that is covered in this section is piecewise functions. I'm going to let you know ahead of time that these are really annoying to graph in more. So remember, I told you if you're not sure about how to do it, then put the question on the forum. If your question is more of, hey, my graph looks right, but Moore didn't give me credit, then hit message my instructor, because that's going to happen to a bunch of you because Moore is incredibly picky with these graphs. So again, you're going to wind up using message my instructor, please, because I want you to get credit and I don't want you to do it 400 times and get frustrated because of Moore. Okay. So if you jump to the answer and hit that key button and your graph looks just like that graph, hit message my instructor. That way I can give you your credit, okay? Now, up here with a piecewise function, when we are trying to figure out, when we are evaluating, we would say, okay, m of -3. We have to decide which of these domains -3 fits in, because then that will tell us which function to use. So for example, -3 is less than 0. So when I plug in -3, I'm going to plug it in up here. It's going to be -15 minus 7. M of 0, 0 is not less than 0. 0 is greater than or equal to 0, so I'm going to plug 0 into here. And then 7 is greater than 0, so I'm going to plug 7 into here. Okay, So with these, you just have to make sure that you're using the domains on the right to determine which of the pieces you're going to plug into. Okay. Now, when we graph these, you're going to have to be using these domains very carefully. So let's start by graphing negative 0.5w minus 7. So that would start at negative 7 on the y. And it would go down 1 and over 2 because it has a slope of negative 1/2. Or up 1 and back 2. Here's the thing though. This function only exists when w is less than or equal to negative 2. So that means that line only happens in this piece of the graph. Okay? And it stops right here at negative 2. And then the graph of the line y equals 1 is a horizontal line at 1 on the y. But that graph starts at negative 2 on the x with an open circle and ends at 4 on the x with a closed circle. The horizontal lines are the easiest. Okay, last but not least, 1.5x, that's 3/2, w minus 6. So start at negative 6, go up 3 over 2. But this graph only exists when w is greater than 4. So it doesn't start until this point right here. That point needs an open circle because we do not have the or equal to. And then I can connect the dots that are on this side. And the dots that are on the other side go away. I hope that made sense. Any other questions about 1.2?